Welcome to the Music and Math Nerd side of the internet. You asked for it and I am delivering. We will be getting into the math of sidebands produced during FM synthesis. Now, if you don't know what FM synthesis is or you need a refresher, you can go to my channel and check out my video on that. But to recap, we have a wave, which is frequency is modulated by another wave, and that modulation will generate sidebands. The question is, how? Now, the full story is a convoluted journey navigating through trigonometry, Fourier transforms, and Bessel functions, but that's a bit much for short form content, so we're gonna skip ahead. The amplitude of the sidebands is a beast we will not be tackling today, but I can talk a little bit about the frequency of those sidebands. And this is the equation that's gonna get us there. CF is gonna be the frequency of our carrier, and the sidebands are gonna be CF plus minus n being any integer, times the frequency of the modulator. Now, to better understand this, let's get into an actual example. Let's say our carrier frequency is 200 hertz and our modulator's frequency is 100 hertz. So let's lay down some sidebands frequencies. When n equals 0, obviously that's not really a sideband, that's just our carrier's frequency, which is 200. When n equals 1, we're adding our modulator's frequency, which is 100 times 1, which is still 100. We get either 200 plus 100, which is 300, or 200 minus 100, which is 100. When n equals 2, we have 200 plus 200 or 200 minus 200, which is either 400 or 0, so on and so forth. I think you get the gist. Now, drawing in my x and y axis here my x axis is going to represent frequency in hertz and my y axis is going to represent amplitude in not D flat, decibels. I'm going to go ahead and highlight my axes in green so we don't get confused. Now, one thing worth noting, and this is a product of that whole prequel to our story that we did not get into, but the sidebands produced by subtracting an odd integer times the modulator frequency are going to be inverted in phase. Also, when we cross into negative frequencies on our chart, that's also going to invert in phase. So we start with our carrier frequency, which is 200, move on to our first set of sidebands, which are going to be at 300 and 100 hertz respectively. However, the sideband at 100 hertz is going to be inverted in phase. Next, we have our sidebands produced by the integer 2, which is really just 400 hertz because 0 is not a frequency, it's just silence. Next up, produced by the integer 3, we have 500 and negative 100, which will be inverted in phase, thanks to 3 being odd. Brief pause here. Note that negative 100 being inverted in phase means it's doubly inverted, thus making it positive. We'll get into the implications of that in a minute. Next, we have 600 and negative 200. And lastly, for the purposes of this little illustration, 700 and negative 300. Negative 300 being inverted in phase.
Whoops, we are out of time, but remember, some of those sidebands will be canceling out with each other, so stay tuned to see what that looks like. Also, don't forget to like and follow if you're a bit of a musician and a lot of a nerd.